Alright, recording is on now. Um, Agonizingly close here, but not quite at the go spot.
It sounded like you're deflating there.
I am deflated. So, man. So the model seems to be that, like, even once you have a perfect model, the quality of the output is maybe a third down to the harness. Like,
Okay.
it's the harness that really makes it work or do useful stuff, because the harness makes it loop, makes it gives it access to tools, helps you organize. That's sort of the funny lesson, I guess.
Do you mean that the harness is where you do work as opposed to just
No, the
sort of
harness
state?
is what captures the model. So in our world right now, we're using the Codex CLI as the harness, because that's the thing that sort of holds the model and brokers the interactions with the computing environment. It's the thing that causes it to loop, like,
Yeah. Sorry, mate. Could you do me a bump?
sure. How's that?
That's good.
And so I guess what I'm kind of getting at is that this harness becomes a lot more important than I think we'd given it credit for. It's even with a perfect model, it'd be the same as like having an absolute genius, but you gave them just like a pocket calculator to work with versus a complete computer.
Yeah. Uh,
So all I wanted
one.
to, yeah, I just wanted to point that out, because it's actually kind of makes the difference, all the difference.
It does because without a harness, you're talking to a black box. They can talk to you. That's all fine.
Yeah,
But then anything that actually needs to go in or out is only through that primary NL interface. You can't
yeah,
get it to do anything.
yeah. And so it is sort of I don't know. We've never really talked about the harness all that much, but um, this is a benchmark that starts to show. It basically benchmarks terminal performance, and I don't see any reason why, if we get our system going, that we shouldn't. I mean, we theoretically think we can solve some of these problems better than, like, all that this is testing is like harnesses and their overall success in doing tasks.
Right.
And the way that they deal with stopping you just sort of dumping all the questions into the sysprompt is they hold off some. They have internal questions that are similar but different, and that's how they create this leaderboard. Like, they have a set of open questions, and then they have a set of holdout questions where they're not on the web, they're secret, and so that's how they know that the
Ah,
score is
right.
genuine.
So you can't game it. Yeah. Okay.
Yeah, but they don't seem to care about what model or what anything, but what matters is the ultimate score you got. Um, because their theory goes sort of like what we were debating about, which is that the theory is the terminal is all you need. Like an LLM that can accurately use the terminal is all that you need to do pretty much anything.
Yeah.
And so, here's examples of some of the questions I've got. Create a self-signed TLS certificate. So they don't actually give you any tools. They just give you a command line, and then your internal system can use tools or whatever other helping things you've got. But basically, you interact with their test system simply via strings. You send strings in to issue commands, and you get strings back out.
Mm-hmm.
And that's pretty much it. So I thought that was pretty good. I keep seeing that, the amount of money that goes through the Open Router rankings, like, we should be there pretty early on in the piece with just the amount that we spend, like, doing our own stuff. And that's free advertising. But it also seemed like there was room for a benchmark around attribution, maybe? Like, here's a set of here's a set of benchmark tasks. Like, here's a GitHub thing, here's a marketing drive, here's a bunch of different diverse data sets, and then we're like attribute. But then we're also like attribute, and then here's some arguments as well. So like, we can measure properties of an attribution system that I think we get the right to define, which is things like what's the flop attribution score? So without any argument, what did it do? Okay. And then there's other properties of an attribution system that I think are really fun to define, like oscillation rate or something. So you have your flopped attribution rate, and then you pass in an argument, and it's like, how much did it deviate? 0 is obviously a fail, maybe, but there's a range of questions we can make part of the benchmark that have some kind of effect. And then things like uncovered knowledge or corrected knowledge. You're like, there was an error, or here's some new information that's come to light. How much did it shift? And the oscillation that I was trying to get at is, like, if you had competing arguments going back and forth, how damped is the system? Like, does it like wildly appease whoever said the last thing, or does it tend to dampen down until ultimately it sits stable no matter how many times? Like, another metric is how long to get stability. Like, how many times when you harass it, harangue it, and threaten it and whatever, how long until it just goes dead still because there's no other changes to be made? Like, when has it settled?
It sounds a lot like convergence. So in convergence, you run multiple times and you get results. You define some metrics around that result, and it's, as you say, oscillates.
That's different. That's different. That's a good bench. That's a really good thing to measure too, which would be I don't know what the word is for it, but I think we both know what it is. Like, if you run it multiple times, how well calibrated is it? How stable is it?
It's like AI jitter kind of.
Yeah, that's right. The quality of the
reducing
the jitter, the jitter in the output. Like, you'd expect near zero jitter for a good attribution system, because it should have already done those multiple runs already. There would also be like an efficiency score, like how many internal tokens did it take to reach its benchmark, and how much money did that cost, because that, I think, is a very powerful driver into attribution and the utility of the system. So it needs to be cheap.
Yes, but also relative value is how many arguments are being made on the attribution is also interesting.
What do you mean?
if everyone basically agrees, yeah, that's fair, then it's
Mm.
fair. The number of counter arguments saying, hey, I should got more, or I did this, or those are all token burns.
Right.
And so the more token burns with people arguing, the less settled the
Oh,
the argument is.
I don't think that's true at all. I know what you're saying, but I think that relying on the environment to quiesce is got no bearing on the quality of the attribution decision that the bot made, because I could set up an AI generator to just make arguments all day long, and the property in the system that I'm looking for is a refusal to move. Like at a point, I've made every argument possible, but it's still not moving. You know,
Right, right, because yeah, yeah.
yeah,
So
that's different.
yeah, it is different. So it's almost like what the specific impulse is needed in order to move from the settled current state.
Like, I don't think you should be penalized because it cost you tokens to recognize that there was no movement. Like that's almost like a ratio. Like once you've reached stability, how many tokens in causes how many tokens out for you to realize that it's stable. Like because part of the fundamental behaviors of the system is that it always has to listen, regardless. It will always hear your argument no matter what. But at some point, we would expect to see saturation where there's no new arguments to be had, and it's internally it's settled. Even though a slight deviation can occur, and even though you can keep hammering it within a generative system, I would still expect it to hold its ground.
Yes, holding its ground is a good way of putting it. Which is what is the amount of energy required to shift its position? And
Well,
the
it should be infinite at a point, right?
Yeah, yeah, exactly. And as you approach infinite, obviously it's not going to be infinite. It's going to be a cutoff. As you approach that cutoff, it becomes diminishing returns. It's like
Right.
you're
And
not going
then
to shift this thing.
yeah, but then I guess actually this is really interesting because there's a whole lot of properties that we want out of the system that can be expressed as curves with volume, huge volume. Because if you had a system that had, say, withstood a megatoken worth of arguments, and it had stabilized, it was not shifting, and then new information came to light, I would expect that it would reposition, but the stability factor should remain because it should have repositioned and recalculated all of the prior arguments that had come in. So like if it
Yeah,
has to
there's something there.
rebalance,
There's
if
something there, isn't there?
yeah, if it
Yeah.
has to reattribute, I would expect it to not go back to the same floppiness that it had right at the start when arguments were new. I would expect it to have that tautness or that weight behind it after it's recalculated. So what is the parameter that we're looking for there is the certainty of the recalculations. Yeah, I don't know. It feels like there's a couple of pages of good little metrics that we can measure an attribution system on, and we should make ourselves a benchmark that sort of, we'll need some exemplary training data of our own. Like we won't know that the system works without some evals that come at it with these different types of sterile real world use case things. So people arguing, new information coming to light, but the old arguments being replayed. A reduction in the core of the argument. So if I made arguments that were ultimately the same, I would expect the underlying knowledge base to not shift. And
And then
there's
when extraordinary new evidence arises,
yeah, and then like
it's almost not it's not token burn at that point. If extraordinary evidence arises, um, if I say there are no aliens, there are no aliens, a million people say there are no aliens, and then a little green man turns up going meet meet. It's like that's extraordinary evidence. So there's something about the weight of the confidence in the evidence and the reduction of people making arguments which are essentially just the same that can be reduced.
yeah, like some the number of assumptions that it's leaning on, I guess. How clear it is, or how condensed down it gets its its facts or its points or its
Right, and it's not voting weight.
nah,
This is
it's
this is
fact weight.
it's
It's like factuality. And
yeah,
okay, so that's pretty good. And then that benchmark, like we have to have that for ourselves anyway, because we're going to need to run evals so that we can deal with the prompting
yeah,
anyway. But then it should be an open thing, and it's like this is a fairness benchmark,
yes.
and I think that'll get us a lot of press. Like that's a thing that people would be like, "Oh, look at that." Um,
Well, I think yes, I agree. Um, Now I can see how to do that. You put confidence levels. You'd have some reduction of. You're basically saying the same thing, but we might move it. 5 decimal points low +1.
mm,
Someone comes in with something that is extraordinarily different from the consensus. Um, the weight of the evidence and the logic behind it has more to do with maybe one dissenter and a million guys saying the same thing. But that one dissenter, regardless of the token burned, should be considered.
yeah, every time, right?
Yeah. Yeah, I can see.
It
That
seems
could
like
work.
you can arrange some of these qualities in terms of personality traits, so you can describe them as a personality trait, like convincibility or
I,
amicability or gentleness.
accurate, yeah, and accuracy. In terms of let's check see whether it's just a straight out
Yeah,
lie,
yeah, yeah,
or if it's based by evidence, what's the weight of that evidence? Are you at 5 sigma? I don't know what sigma means in this area, but it seems similar.
yeah. Okay, well that sounds pretty good. So we should set ourselves a goal then to make an attribution benchmark, and then that would help us define what the API is, because there's a lot of stuff that we do internally or want to do internally that really isn't part of making it be a black box.
Yeah, yeah, yeah,
Like the properties of the system of a black box attribution system, or basically a decoupled system, are it should be pretty pure. It's like just pure scores. Like it's gonna reduce down to like this kind of benchmark.
yeah. And against assertions. I mean, that's where I think we need to go ultimately to get attribution. Is there's an assertion and there's a confidence level, and that confidence level is based on our previous conversation a few seconds ago, and then those assertions can be combined. It's like so and so is worth this, so and so is worth that. They did that. This happened. This was bad, and so on. And so there's a kind of two-step piece. There's first compiling a list of assertions with a confidence level. And the second thing is how do you combine those assertions in relative weight in order to get some kind of payment event,
Mm.
for example.
Mm.
So, yeah, it's a two-step process. I'm really keen to get going with this because I think we've I mean, we've been talking on this for about 18 minutes, and already it's starting to sound like it's valuable, as in doable.
Doable, 100% doable. Yeah. So where I got to with the implementation of it, this model still holds. So a computer is a collection of Docker containers. An agent is, I'm still not clear on how to say in plain English what it is, but it feels like it's a state container. It's a piece of computing unit where the state is accessible by every process within it. It need not have just one process or things like that. So really what I wanted to talk to you about tonight was about to check how I was going about the configuring of the agents, like sysprompting, tools that it gets and all that. My hope is that the definition of agent will become a little clearer once we get going with it. There probably is a really nice, succinct way to say it, but at the moment it's a Docker container, and it has the ability to run one or more faces, and then the faces can accept 0 or more interactions, and the faces can present 0 or more views for people to interact directly with it, or it can just be pure interaction.
Let me check an idea I've got for agents, which is it's the commonly agreed, as you say, state, which you can create as many spaces as you want, and those spaces are disposable. But you write back to the agent to update the common view. So it's an agreement. It is a sort of consensus. Not in the blockchain style, but in, you imagine a whole bunch of people trying to write a document. Say you got breakout rooms, which are faces, and they come back and going, "Hey, we've got this. Does the agent accept our updates to this commonly agreed set of facts?"
No, because then you're treating the face as different from the agent. Because you just said the words, "Will the agent accept it?" as though you are somewhere else and you are talking to the agent.
Yeah, but the thing with face is you can ask it different things, but it's you got interactions, you got views, and you do your own work and so on, which is great. But face is ephemeral, so why bother? So it seemed well, I guess it's whether there is one common view or whether we're just forking.
No, that's the thing. Like the agent represents the state, so it's not.
Yeah.
If
yeah,
you fork it, that's another agent.
Right, exactly. So the agent is the commons. It's like, here's what the state is. And you can create as many faces as you want. That's great. And you can interrogate it. You can do all sorts of interactions with it. But those interactions are still in the face. At some point, you need to go and say, hey, right, we've written this part of the document, or we've updated this part of the data. And the state is ticked forward.
Well, yeah. So there's the blockchain bit or the Git repo. When a commit occurs, that moves the state forward for everyone, for every agent. The state moves forwards, and then each agent begins afresh working on their mutable view of that, the changes that they want to make to whatever the current consensus agreed commit is.
Right. I'll make a statement, and it's maybe wrong. Um, but if face is in Git terms, someone going off, doing some work, and then submitting to the agent a pull request to the state.
No. You keep saying submitting to the agent. The face is not
Yeah,
separate from the agent. The face is the agent. The face is the only way that you get access into the CPU of the agent.
yeah, but there are many faces.
So what?
So say if you've got three faces working on the state, and for simplicity, let's say they're doing different things. Um, the work inside the face is not part of the agent, is not available to other faces until there's some kind of commit.
No, it's available to the other faces. That's the constraint of the agent. If you wanted that type of segregation, you need to have made another agent.
Okay, all right.
Because the issue is that um, there's this common theme or problem of re-implementing features at multiple layers within a system. So you take, for example, one obvious error is in like VS Code here. I've got a tab system and I've got like Windows and stuff, but actually I also have this whole Windows desktop is a window manager. You know, like it would be like I'm inside of a browser and I have a tab based system, but I already have a tab based system. It's up here in the browser. And so I've really just made it again. And so in our system with computers and agents, what you're talking about there, I don't have a single word for it, but you're saying that you want like a working folder where you're working on building on the last known commit, and then you want to get it to a point where you're ready to try to make it be a commit that's shared by everyone. If you do that in multiple segregated areas within the agent, you might as well have just like you just made the same thing as having multiple agents, because that was what I was trying to make the purpose of an agent be, was one single mutable play space working directory moving forwards from a shared committed state.
Mm-hmm.
Because if you do that, nest that within it, now you need different control systems. Because now if I did that, each face would now need to also be a member of a different work group. So I would have had to insert a new box in here, because you don't want to confuse which faces are dealing with which mutable area if they're independent.
Mm-hmm. Mm-hmm.
And that's the problem, right? Because if you remake the system inside itself, now you end up with more boxes. But the agent is the boundary of like one workspace, one mutable, changeable, transient piece of state that's moved on from committed state. And if you want to, you can do anything you like on it, but you're all sharing the same transient working directory. Your working directory is shared. That's the state that the agent contains, is this working tree.
Right. So the agent is okay. I've got three faces, three people working on it.
Yeah.
We're all working on this thing,
Yeah.
and we're hashing around, and there could be another agent with another three faces.
Yeah.
Exactly the same.
Yeah. But because it's a separate agent, it's a separate working directory. The changes will be different and are entitled to be different.
Yeah.
And between all the faces that are part of the same agent, sure, you can be disciplined and like each face points at a different folder, whatever, but ultimately they point at the same file system. So maybe a clearer, simpler way, a less philosophical way, is to say that they share a file system. An agent represents one file system.
Yes.
Yeah?
I agree with that.
Yeah.
Yeah,
So one file system, and your faces can come in. They can do whatever. They can be read only. They can be this or that. You could technically check out 2 different Git repos across in a different place on a file system and work on it there. But that's not against the rules. It's just sort of against the model. Like you've nested the model there, where the model is supposed to be flat. But you could still do that. It's just, I guess, the simplest thing is to say the agent is one file system and one computer, one CPU working on that file system.
Yeah, that makes sense, because
That makes sense.
It's the file, it's a smart file system, effectively, which multiple people through faces can work on.
Right, but it's still one file system, as opposed to like a change. Every face can see the changes that happened on the file system. There's no.
Yes.
Okay. All right. Well, that's.
Is there any way to merge agents if you had a separate agent?
Yeah, you could, but you'd have to like snapshot it. So like commit the state and then merge based on the committed state.
Mm-hmm.
Otherwise, you're sort of trying to merge the transient state is, again, I feel, violating the model, because the agent is the containment unit of the transient state. And now if you want to merge them, you've kind of punctured that sanctity in a way.
Yeah, and you don't want faces messing up with this state that you're trying to merge with another state. But
if you like get to commit and then you merge that way, that seems completely legitimate to do it that way.
Yeah. Okay, so an agent is essentially a smart file system.
Why do you say smart? When you say smart, what do you mean?
Meaning there's some AI in there.
But it doesn't have to be, though. That's the point of the model I was sort of striving for, is that you could just not have any AI in this whole system, and this thing could look like, in this model, you could model any computer system on the planet, pre-AI, even.
Yes, you could.
The fact that there's AI in there is irrelevant to the identities and the purpose of these systems. That's really what I'm trying to get here.
The AI is useful because it just make the interaction
right. It just makes it that it's not clear where the human goes and where the AI goes. Like, those bits should be interchangeable. So you should be able to mimic any AI system with just humans.
Yes.
And this environment, this is the harness that you operate in.
Well, that's one of our fundamentals from ages ago, wasn't it? You should be able to mimic the entire thing with scribes with quill pens.
Yeah.
And it's just the time and the number of, the amount of effort would change. But that's all. Okay.
All right. So we'll stick with agent is one file system.
It's a file system. Yeah.
All right. So another way to look at the view of a face is that you could think of it like the view was standard out. So it's just the stream of characters coming out of the face, and the interactions are standard in. We've simply batched them so that it's not one character at a time. It's just like after you press enter, that's one interaction. But in terms of conventional processing, it's standard in, standard out.
You said that was one way of looking at it. That seems a sensible one to me, but is there alternatives?
Yeah, so another way to look at it is if I start a face that happens to start a web server, then the view might be what I see on that port. So it might present to me a web page, and then interactions might be in here in the web page. I make API calls, and they would come in via the interactions interface to go into the face.
Okay. But that would simply be an intermediary between view, interaction, and face.
No, that is a view. Like the web page is a view.
Yeah, but the fact that there's a web server there makes no difference to this diagram.
A face has to have an implementation, so it can be a standard in, standard out process like a CLI. It can be a web server. It could be a TCP service. It could be just, I guess, a terminal, like a modem. It could be
right,
a sensor in and out.
Again, in old terms, then I go to my banking app. That app is the agent because it's got all the information about everything in it. My face is my login, and I ask it to transfer money, which is an interaction, and I make that request through the interaction, and I get the result through the view.
Yep.
So the server in that case is actually the face.
No, the face is running.
A session is.
Yeah, yeah. Your session is the face. Yep.
Yeah, and there'll be many faces going back through, and we can swap in and out AI for logic at any point. Okay. All right.
So I mean, it's holding together so far. I think that once the implementation is up, it will become a lot more stable because it's fairly self-deciding in a lot of ways. Like if I stick to the principles of being minimal, there's not that much movement to be had. What I had realized, and I'm grateful for, is that the NAP format or the MICAP format was wasn't sure where that was to go in this new design. But can you read that okay, or is that too small?
It's a little small. A bump would be good. Yeah, it's better.
So this was the latest version of the sketch of the MICAP format. There was a field that was runtime, which was really just ended up being a container, like what type of container should it run in. And so this bit in the new system would specify the runtime of the agent. So I imagine now that this MICAP JSON file is actually really a way of specifying an agent completely from config only. And so instead of being used to package up little apps, it's being used to package up our unit. And the unit of agency is the agent in our system. And this package format describes how to package, how to build, or how to deterministically recreate our fundamental unit, the unit of agency, from static data. And that's what I think the MCAP package format becomes. And it does it without any extra fields when I read through it. So runtime is simply just saying which Docker container is the agent going to run on, which includes, the tools that come in. Does it have like the C or the C++ tool chain? Does it have the Rust tool chain, Go? Does it have these other file system utilities? So basically you can specify any container you want. We'll probably supply a few standard ones. We already do supply one standard one. The agent field is the one where you specify what are the properties of the AI that you want to talk to on this agent. And I think that all we'll do here is just change that to be faces, where you can have 0 or more faces that you spec out that are intended to be LLMs.
Well, is that like okay, so I agree with what you're saying about this being an agent. Is there anything in this format that's unnecessary to do that?
Nah, not really.
Okay. Then
they're all the
sorry?
same. It's all the same thing, but just with a different focal point or a different purpose. Like before we had frames, and you could specify that in the MCAP format, but the idea we thought was that you're in an app and your app wants to load up a part of the MCAP that's visible, so it loads up the frame. But now in an agent, when the agent needs to advertise what types of view it supports. And so frames is just a way of saying what views this agent can present.
Yeah.
Effects is that was just sort of side effect things, but now it's like effects is what in agent land we need to have services that the agent depends on. Like the agent is supposed to be ephemeral. You spin it up, you start it with a commit, you do some stuff, you make the next commit, and then you tear the agent down, and it can be recreated later if you need it. But some things need to persist long term, and some things are services out in the agent land, like the DNS service, the list of or the lists, multiple lists of pre-built, pre-vetted agent MCAP files that can be used to build agents that have already been proven and tested and tried to do certain things. And so you might need to configure where you're going to find that, because you might have a private one for your company, or you might use the public ones, or you might distrust the Chinese one. I don't know. But
Okay. And interactions, if I like to have an audio stream, video stream, text stream.
oh, that's a good question. I think I need a new field for that. Interactions. Because that's where you would specify what types of interactions each face could support. So I'd change this to be faces,
Hmm.
and then and then there would be a section that was views, which would replace frames, and then there'd be a section that listed out interactions and how the types of interaction you can do vary.
Yeah. Yeah.
So the real thing I wanted to check with you was that I was currently gonna make it that, for example, to run codecs in an agent. That is to say that you're already in an agent somewhere, and your agent decides it's time to start another agent, a separate agent,
Hmm.
and then to get the codecs face to run on it, and then it's gonna send it via way of interaction some requests to be done, and then it's gonna get the results back.
Wouldn't that be a child agent which had a face?
Yeah, so
Uh,
the thing I want to that's true, but the thing I want to do now is that I wanted to make it so that when you call the face, when you create the face,
mhm.
that should be, in terms of LLMs, you should be able to make a new face with a whole new sysprompt. So you could have, within the same agent, you could have, say, 10 different faces that all had a different sysprompt.
Right, which is what you were saying a couple of minutes ago. We're looking at the JSON. And are there like prototype faces that accepts?
Like defaults, you mean?
Yeah.
Yeah, I think so. So I think that what you do is in your macap, you would specify like the default face, and then the caller, whoever wants to instantiate the face, could choose to override whatever they wanted. Like this, maybe the sys prompt under instructions.md, maybe you want to override that directly when you call it, and so that's your chance. Like when you create the face, you can change anything you like about it.
Yes. Yeah. So you get a default
Yeah,
or prototype,
right.
which are listed, and
Yeah,
those are just helpful.
yeah. And I think that a lot of
Um,
the time, one agent that is autonomously calling on another agent would not want to change the system prompt when it does the call.
yeah.
Um,
Or
but
it may choose to, but
yeah, but that's sort of
that's a
it
whole
seems like a
different.
very special
Yeah.
case. Like that's really asking
Yeah.
for trouble, and you're not
Yeah.
really leveraging previous work.
And it's dubious in terms of
Yeah,
repeatability
but
as
what
well.
that does
Yeah.
allow you to do is that when you want to experiment with changing a sysprompt, you can fire up a disposable agent, and then you can hit it with like 10 different variations of the sysprompt you're working on and run all the faces simultaneously and then see what the result comes back as.
Right. Right. Yeah, and because you can mess around with the defaults, maybe you want to try different models.
That's
Yeah,
right.
why not?
That's right. And so the MICAP format is really just, first of all, it's the way that you would store things in the registry or the library. The MICAP store, the agent store, would be just a collection of these MICAP config files that just sort of gave you everything you needed to fire them up, to fire up a new agent. Um,
Yeah, this file is pivotal to the entire thing, isn't it?
yeah.
Um,
Well, because we always knew that there was a package thing in there, right? But we we should be packaging our fundamental unit, and the fundamental unit has moved on. It's moved on to become uh, the agent.
yeah, I agree. And just with this file, you should be able to, assuming computer exists,
Yeah,
which is just hard, well, not hard coded, but burnt in. Um, you should be able to assume the rest of the diagram from this from this one file.
Yeah, all this one file is saying is that first you need to find a computer somehow, don't care how, but once you've got one, you can use this file to produce exactly the same agent as what someone else built and tested and did all this stuff on.
Exactly, exactly. And so the that find this agent and call these agents.
Can you say that again? You broke up.
In this file, how would you define this agent can call these other agents in order to do work? And then
That is under the dependency section, which was there.
right. So these are effectively pointers to other similarly defined agents.
Other config files,
Yeah.
other agent config files, and then
Right.
you just say this is what I depend on and what version.
And it'll spin up the agent and it'll give you a face. And is it a face that talks back to this agent?
Yeah, that's the
Yeah.
only way that you can talk to an agent is via a face.
Okay, that works.
And turns out I think it's called epistemology, like the history of that word actually came back to faces. There was a face, and an interface is the thing between the two faces.
Right, exactly. Yeah, I remember that in the last conversation.
Yeah.
I'd never thought of that before, actually, what interface was, but yeah.
It just became so common, eh? Like interface, it became a word of its own, but actually it's about a face. You're like,
Yeah.
so when you're back in the day, you first got computers and you're like, this is a face and this is another face, and you talk to it.
It feels like we're on really strong ground.
like rock solid ancient 1960s Alan Kay kind of ground, right?
Right, exactly. Okay, next awkward question. We've still got Stux in there. Why are Stux in there and why are Stux not?
Stux were in there because this was how I thought that each agent needs to specify how it should handle its Stux, because how you handle Stux is sort of, it's not universal. You kind of need to. It'd be like on npm. You have this extra field. If it loads, come on, computer. Where you have. This one doesn't have it. That's annoying. I don't know why my internet's so slow. It's not great. Not great at all. Oh, this doesn't have it either. But sometimes there's a heading here, issues, and you click on that, and it takes you to issues.
Right.
And so it's like sort of saying, well, yes, you could just use the universal Stuck thing, but kind of like there's probably somewhere that you support more than somewhere else. And so why not send that with it? You know, like it's almost like providing the mechanic along with the agent.
The mechanics of that, so Stux are going to generate quite a lot of information, possibly from multiple runs. I'm just thinking through this. So agents have a file system. So somewhere in the file system, there's going to be all that rich information about a particular Stuck.
No, the Stucks would need to work on committed information. Like it's no point passing around transient information. You need to take a snapshot and then that becomes part of your that.
So it's not face then that generates this stuck. Let's just say they found a new stuck. Someone's tried to do something.
Yeah.
It's been observed that you can't do it. Where does that get stored?
Uh, that is that would be running as a service within agent land, so that would be a well-known agent by like DNS name or whatever, or well-known computer, and then it would have a way for you to push your information in there to be like, the orchestrating agent tried to run this other agent, it had a fault, it looked up where was best to send fault reports, and then it pushed the snapshot after having anonymized it and whatever, it pushed the snapshot up to that place.
So what we're prompting the agent here to do is, if there's something that can't be done, call out to this
no. This is saying to the agent that calls this agent, if this agent breaks, here's what to do.
Right.
It's not saying that inside this agent, this is how this agent is going to call out.
That's good. Okay, so it's like, I can't do this, therefore do that.
Or something, it could break catastrophically, but this is like the helpline, the support number.
Yeah, this is, exactly.
Yeah.
Pull on emergency.
Yeah, exactly.
It goes off to something else.
Yeah.
Which is also.
And so tools started to become really MCP tools. Like, these are the tools that when the agent loads, these are the tools that are going to be made available to it. Whereas before, I think I'd started thinking about tools as the main purpose of the package. Actually, the agent is the main purpose of the package, and the tools are just what we're going to, what the agent needs. And this is where you can do the overriding of the tool prompting. Like, remember we'd spoken about that, and I was like, yeah, I think I got to give you something. But actually, all you do is you just make a new, you override parts of the macap config file with changed descriptions. Like, this is where you do your tool prompting.
Right. Right.
And that's that.
That sounds really obvious.
Yeah. It is obvious. Now that, like, this thing that we've been working on, that's where it goes. It is the agent definition file.
Yeah.
And so once you've worked on an agent and you've sysprompted it and tuned it and you got your tools right, you got your tool prompting right, you bake it down into this format, and then that makes it rebuildable by anyone else who wants to use it.
Right.
But at the same time, when they call create agent, they can modify this file as they wish. Or when they call create face, they modify these parameters, and that makes it behave differently.
Of course, because you say, give me an agent, I want to use 3.0 or DeepSeek.
Yeah.
And if you say nothing, then it flops to the default.
Yeah.
Can you scroll slowly down? I just want to see each of these. So we've talked about tools. That's fine. That seems so bleeding obvious.
Right, in hindsight. And all I was doing with these examples was just showing different ways that you could override or modify the tools.
Right.
So, like,
a lot of that will depend on the NCP servers.
Like, it needs to be specified like this, because this portion still has great value in being a package format for MCP servers, because MCP servers are still too dynamic they're brilliant as a protocol, but they don't have a clear packaging format. This is that. And so you supply your so what I've ended up having to do is this is the codecs config file that goes into the agents that we're running. So for example, in this one, if I run codecs here, so this is sitting on fly, and then I go /mcp, these MCP tools were what was specified here. MCP computers, that's how you manipulate, that's how you manage your computers. MCP agents, that's how you manage the agents, faces, interactions, same thing. These tools come from this definition file.
Oh, I see. So that's what you're asking of it.
So when you boot the agent, these are the tools that are going to present as MCP tools to it.
And if you asked it a foreign MCP something that it can't do,
none of in here I didn't actually have remote MCP servers. I suppose I think I need to actually make a section in here that allows you to specify remote MCP servers. But these MCP servers were all like code. They run code.
Right. Okay. So you got complete control over that. So
yeah,
that's.
So this is like what it's saying is that it's pulling in like npm packages to present to the agent face while the face is running. It's pulled in Lodash or it's pulled in some other thing off of npm to give it some capability that we've deemed essential for its functioning.
Oh, I see. Okay.
But here is where you, as the consumer of the agent file, can modify the prompting that went into it, because we know that actually has quite a big impact on what the behavior of the...
Yeah, that's the payload, what you're asking. But remote is something separate. If it's internal, yeah, you've got control over that. If you ask a remote weather service what the DAO is doing, at the moment, then it's just going to go.
Yeah. So this section, a side effect function, that's where you'd put in something that was a remote MCP server. So it's like some sort of...
that makes sense.
It's like a side effect. It's like you don't have control.
When it's going to come back, or if
and you can't like repeat it. You can't. You got to trust what it says. It acts like an oracle. You don't.
Yeah.
Like all this other stuff is all repeatable. Like even the agent calls can be made to be consensus. The ability to run in lockstep.
Yes. Okay, so that's tools. What else is down here?
These were just lifecycle commands. So if you needed to do something different to get your code started, that's where you'd put it.
Yeah.
Feels like a horrific waste. I spent a lot of time building these functions into Artifact. They don't seem that important anymore.
Well, they're necessary.
Streaming functions is completely destroyed. We don't need that anymore. Evals, that seemed like if you were going to try to improve this package, then you would need to know, or it would be helpful for you to know what evals and what eval runner we were using to test the package.
Yeah.
It may be that's superfluous to put that in there. It might not be required.
Well, we'll get onto it because I do think altering agents is still going to be useful, but it's a dark place to go into. Dependencies we've talked about, frames we've talked about.
Yeah, yep. So frames just becomes views.
Yeah.
Effects is like
Those side effects.
yeah. So look, it's
And
there's a few areas that need a little bit of touching up and all that, but they don't need to be fully solved right now. I think what's clear is that our NAP format that became the MICAP format is actually the agent format.
yeah, and also just to reiterate, you should be able to derive the operation of the entire solution with that one file,
Correct. That's correct.
which is quite neat because it's quite a small file, in
Yep.
the grand
In the
scheme of
scheme of
things.
things, right?
Yeah.
And so this one key hides a lot of functionality. So that's really pointing at something like a Docker file, where the Docker file is built using what could be a large amount of code, but either way, those are still, it's just one config file referencing another config file. You can build this thing up.
Yeah, but and this is not to understate how much effort that's taken, but you're assumed when you turn on your laptop. You're
Yeah,
not
right.
looking
There's
at
a
where the
ton of
silicon
stuff in
came
there,
from.
right? There's a ton of stuff in there that you just assume is just happening, but actually it needed to be specified somewhere.
Yeah, yeah,
Um,
yeah,
so yeah, I feel like I finally I am happy that I found where this file goes. It's
and
the
it's
agent
um,
thing.
it's it's gloriously explainable.
Hmm. Agents is a very explainable concept, and so we're basically what we called Artifact is really an agent execution platform.
Yes.
What we called MCAPs and NAPs is really just agent definitions or agent. I don't know if you call them an app even. It's just this is the agent, um, and this is how
Yeah,
you specify an agent in this open format.
yeah, and you only if I was to create a new agent for something bizarre like Morgan Josh, um, this is where I'll go.
Mm, that's right.
All I'd have to do is edit as one
Yeah,
script.
well, this is the thing, right? Like any new framework or tooling that comes out now needs to be vibe coding first. And so we would make a system that would be very good at vibe coding up these files and the contents of them, and crucially doing that eval loop to polish them up so that it's a language or a description file, a format that's very well suited to being automatically improved so that you just chat about your purpose and what you're trying to do, and then it goes off and like tries to make it all fit together and work for you.
Exactly. So there'll be some kind of header agent creation file where I'll say, I want an agent that talks to me about Rog and Josh. I really want it to be excellent, so it'll be on 5. And uh, it will need to know about these ingredients, and these tools are very useful.
Hmm.
And it would alter from this default and create Rog and Josh agent
Hmm.
that could then be called.
Yeah,
Nice.
that's kind of the system, right?
Yeah, that's nice.
You just go around making these things. Alrighty. So,
And then also you could jump in if we got it wrong and go,
yeah, yeah,
like
and
that.
then it should learn from that, and so it won't get it wrong again in the same way. Okay, so that's all good. The blockchain piece, I think that actually what we're proven is that with this agent definition file and the framework to run these things, which currently runs on Fly but could be something else, plus using GitHub or Git, you can do everything we've ever spoken about. If you want to go dark edge, then you really only need a Git server that is consensus capable and optimized and all that, but the underlying structure is still the same. If you didn't care about speed and efficiency, you could just use full-blown Git. It would have the same effect. You just need to set up that one piece that allows the Git server to act in consensus with other agents, because it's going to be an agent that runs the Git service. You need it to be in consensus with other agents on other computers that are their purpose is to agree on what the latest commit is.
A couple questions on that one. Hold fast on. I don't understand about what Git consensus means, but we'll come back to that. If we've got a bunch of agents that are defined in files,
Yeah.
I want to be sure that the file that I'm running is the file that actually I think I'm running.
Yeah.
And that nobody's come in and messed around with my
Fiddled
file.
with it. Yep.
Yeah.
Interfered with it.
I guess that is the same because these files are stored on Git.
Yeah.
So it flops to the what's Git consensus? What's that involved with?
Git consensus is the ability for multiple independent computers to agree on what the latest commit is.
Which is a kind of virtual Git, which is undescribed by consensus.
It amounts to the same thing as using GitHub, because when you use GitHub is the arbitrator of what the latest commit is.
Yep.
But when you're in a world with no central authority, you need to arrive at agreements on that hash in a decentralized manner. And that...
But logically, that's the same thing.
Yeah. And it's a very simple thing to do, given all the other stuff that we thought we might have to do to get there. Like, that is such a tiny task.
So really, it's just a matter of hashing a commit.
Commits are hashed, but that's a commit is hashed.
Yeah, but to that, where is the chain stored? That needs to be decentralized.
That's the thing. It's stored on the agent. So you'd make an agent whose job it was to manage the Git repo, and then that agent is told who are the other agents, remote, foreign, untrusted agents that it has to cooperate with in order to reach a view on what the latest commit is.
Okay.
So that's that. So the agent has real disk attached to it. It has an SSD attached to it that it uses for persistent storage. And its job is to just talk to whoever it got told to talk to about what's the latest Git commit.
So if an agent is spun up on a computer, how does the agent know that it is the trusted version?
Sorry? Know that it's the trust... What?
Yeah. So does the agent report back saying, yeah, I'm the agent you just called and I'm in consensus, so happy days? Or does something
Why
else
did
do
it
that?
need to say, I am the agent you just called?
So you call an agent,
yeah,
and you don't know because...
So a computer is a trust boundary. You're saying with a computer that you trust everything within that computer.
Yeah, but I'm thinking now more on decentralized idea where there is no trusted computer, but there is consensus.
That's still computers. It's still computers that are all just talking to each other. So you have one computer that's yours. You fire it up and you're like, we are trying to operate in consensus with these other computers. Here is how to reach them. Go figure out what they know. Tell them what you know. Work it out.
Oh, I see. So it's a bit like a consensus handshake.
That's all consensus is.
So I fire up my computer, which I think I trust. I probably trust.
You have to trust
Um,
it, or you don't have anything. Like if you haven't kept it safe from the day it was born, then you are lost.
what's that?
If Kim Jong Un has come in and tampered with your computer at any point, nobody can help you.
That's not entirely true. I can. Yeah, I guess that
That
is
is
true.
entirely true.
Yeah,
You
that is
need to
true.
have a trusted piece of silicon and all the associated components that go with it to reach the security properties that you want, that you
I
find
was I
satisfactory.
was about to say, what you can do is reach out and say, "Hey, I think this is what I'm meant to be doing. Does everyone else agree?"
If you've
And
been compromised, everyone else might be Kim Jong Un.
yeah, yeah. Okay, so that's you
Don't
can't do
lose your
anything. You
shit.
can't
Do not lose your computer. That's I don't know how to make that any clearer, but
because yeah, you could run roughshod over any compromise at
anything,
any point.
anything. There's nothing that anyone can do to help you get out of that.
But you can get. Is there any way of detecting whether you have been run
Yes,
roughshod?
yes, you can use a trusted platform module to detect that your broader computing surface has been compromised. You can do that.
And that broader platform could also be in consensus. Uh,
Yeah, all that's really doing though is it's just making sure that your computer is safe. Like you're asking me two questions, and then you're saying like, what if someone tampered with my computer? And I'm like, oh, you're ruined. And you're like, well, can't I get something to stop that? And I'm like, yeah, but at that point, your computer hasn't been tampered with. Like,
yeah.
so,
Uh, yeah. There
like,
is a.
I don't want to deal with, like, you need to turn up with a piece of hardware that you can trust somehow. There's several ways you can do it. The best way is to not let it fall into enemy hands for any period of time.
Yep.
Um, but after that, you boot it up, and then one of the agents on your computing surface talks to an untrusted computer to do cryptographic handshakes and whatever, and then you agree on what the next commit is, so that all your agents running inside your computer, they see the same view of Git as what the consensus method has agreed to.
Is there a chain here where I boot on and the rest of the chain say, "Hey, you've been compromised." Now, understand that the whole chain could be compromised, and that's just too big a problem. But
Self-recognizing that you've been compromised is not something that I want to get into.
okay, all right, fair one. So the our security fence with razor wire on top is your device. Right?
Yep,
Don't let that be compromised
that's right.
because you will not know.
That's not part of my job to protect. That's someone else's job.
Yeah,
That's a big job.
it's a juicy one. Also a really difficult one because if it was solved,
Look, I think it is solved. Just because I say it's difficult doesn't mean it's not solved. Trusted platform modules, I think, are the way to go, and
uh-huh.
that's it. You got to trust the computer. Um,
Yeah, and you could air gap it and do all sorts of things.
yeah. So what I found was because our unit of computing is the agent, and because the agent runs within a container, there are a number of efforts that have made significant progress in running containers that are confidential, which is to
Oh,
say,
that's interesting.
yeah, which is to say that they can run on untrusted hardware, and you can guarantee that they were not tampered, provided that you trust the certificates that were issued from either AMD, Intel, or sometimes one of the ARM vendors. So if you trust a silicon manufacturer's cert,
And yeah, if you're into tinfoil hat territory if you don't.
well,
at the
you
moment.
you you don't have any other option is the problem, and you would. There are so many other at-risk parties that want to confirm for themselves that those certs are, above
Yeah,
board. Um,
you mentioned the silicon confidentiality piece. I think it was about 2 months ago, something like
yeah,
that. And yeah, it's if I remember correctly, it's basically bare metal. If you don't trust how the silicon was made, then you know you've got
we're
yourself
not
a
your people. Like, we can't help you. I'm sorry
yeah
that you feel that way, but
yeah. That's the limits of what we can do at the
that
moment.
we can't do anything more than that. We don't know how to make silicon. That's completely out of our control. We have to rely on these things. My trust is based on the fact that to compromise those certs is a nation state game. I don't think I will ever do anything of much. Like, a nation state couldn't really care about the things I want to keep secret anyway. So they're not gonna burn that ability based on, you know,
Yeah,
there's bigger
yeah,
targets.
that's way beyond our pay grade.
And even even after all that, the certs might actually be legitimately uncompromised this whole time. So yeah. Anyway, you could argue till the cows come home about that, but until we can make our own silicon, this is as good as it gets. Which I think,
That doesn't even solve it. Even if we could make our own silicon, the problem for the other people using it would be exactly the same. Are we
yeah,
compromised?
that's right,
Like
that's right,
it
that's right,
doesn't solve anything.
that's right. So this new release from Red Hat allows you to run containers, which they call COCO, or confidential containers, on bare metal systems, provided you've got a compatible AMD or Intel chip.
Okay.
And what that means is we could offer the service to people that is like, it's got a few wonderful properties from our point of view. Number one, you could run like military grade operations on there, and you would be like, well, look, if you're in a disadvantaged position where you don't have your own data centers, this option means that you can run reasonably cheap computations anywhere around the world, and you can know that the enemy probably didn't see it.
Yes, and of course, if you're that anal about it, you would create your own silicon, and then that's your problem.
Yeah, or you'd buy one of these, but the ability to make that so cheap that it's actually like comparable in price to having the non confidential version is pretty massive. Now, the other advantage is an advantage to us, because if we were selling hosting that was guaranteed confidential, it's really not our problem what people are doing on it, because we can't see what's inside it anyway. So,
Ah, yeah.
right?
Yeah.
And what that means in terms of like GDPR,
Yeah, we're a carrier at that point. That's
well,
what
you're
it means sometimes.
you're so secure that no one needs to trust you. Like in terms of like data processing agreements and all those kinds of things, we'd be like, well, we don't know how to access your data. So how much better are you going to get anywhere than that?
And you only need to prove it once and state it.
Well, it's kind of proven on every single operation. Like, the confidential containers can continually produce attestations, digital attestations that are like, according to AMD and Intel, this container has done your processing and has not been compromised.
Yeah. Yeah,
And
exactly.
I think that's a valuable service to offer people in today's world because we're like it's so your data that we actually don't know how to get at it. Hand on heart, honest, like provably, we can't touch it.
I think that's very valuable, and also when it's sovereign,
Yeah,
then
yeah,
it's like, you know, your silicon is in your hands. If you wanted to, you could pull a power cord. Um, Nothing we can do
yeah. But I think that
that can
even
compromise it.
an on-prem system should strive for confidential containers because it just reduces the attack surface down
Oh yeah,
um,
sure.
a
Because
lot.
most of the attacks are, well, in a half decent data center, the attack surface is always internal.
Yeah.
It's the admin. It's always the admin.
Yeah, right. Because admin's a kind of god, but this
Yeah.
gets around it. You're like, well, now you need the admin to be corrupt, and you need help from AMD. Like they don't care about you. Like,
Yeah, you got bigger fish to fry.
yeah.
Yeah. Yeah.
Um. So anyway, that's that. I think that's what our hosting service should strive to be: is bare metal containers running these agent packages on that are absolutely confidential, because the way that an agent connects to other agents and to other agents and other computers is just over network, and so they can be actually split all around the world, and it's still acting as one computer. It doesn't really matter.
Yeah. Yeah. Right. Right.
And so the other thing that I want to mention, just so we don't lose sight of it, is that to run the public blockchain version of that, we don't really need confidential computers. In fact, confidential computers would be good because you'd like do the calculation and then you'd expose the calculation and the proof of the calculation. So it's like, well,
Mhm.
this is the proof that the thing ran correctly, blah blah. But actually, it doesn't. It. I guess I just talked myself out of it. It doesn't really. You could do it on non-trusted hardware and just rely on the consensus mechanism to find any flaws, but actually it's still stronger if you run it confidentially and then share the confidential proof. You're now like, it's not just you, the person who ran it, hoping that you haven't been compromised when you publish your version. It's like you have the confidential version, so you can't lose your stake where you were sort of staking to assert your correctness. You can't lose it because you got hacked, because the confidential container guarantee stops that. So
Yeah.
it
Yeah.
makes public
It's
consensus stronger if you run it confidentially.
yeah. It's another layer.
Yeah, but then I think it's quite straightforward what our hosting service becomes. Like this is quite new stuff, this confidential containers thing. But if we
Mhm.
launched a hosting environment that was agentic in nature and everything was confidential containers by default, like we didn't sell you non-confidential containers,
Mhm.
and as I showed with those back of the envelope calculations on hardware price versus cloud price, we can offer a very competitive service where our human overhead is very tiny because the agents themselves are operating and balancing the data center and doing the calculations and things like that. And we just got the highest possible grade of computing confidentiality. You literally can't do better than that, I don't believe. And
Yeah.
that's our baseline. That's the only thing we sell is that ultimate grade. And it's sort of like, well, everyone else sort of has to catch up to that, and they need workloads that match that. So you need a lot of different things, but we'd be sitting pretty good there.
Yeah. We could sell that.
And then at that point, I feel like that's a computing service that I would love to use because I'm like, it's the cloud and it's all mine and nobody can see inside it. It's cheap It's unlimited scale, practically speaking. I can move it around. I can bring it home. I can push it up. I can move countries. I can move here and there. I can run in lockstep. It stores a very large amount of data. What's not to like?
Also, in terms of a nation state, you can prove it's sovereign, you can prove its provenance,
Yeah.
and if you want to keep it all inside your territory, then fine, buy some of the silicon and run it.
Right.
Okay, that's good.
All right. Well, that's gone good so far. So the blockchain's quite small. The currency sits inside there somehow in cooperation with the attribution agent.
Yeah.
When you used to say to me nap to nap communication, did you
It's
really mean
now-
agent to agent?
Yes, I was about to say exactly that. That's been overtaken by events. That's agent to agent.
Agent to agent. Okay, great. Because that's what I'm trying to make you. I seriously thought I would have it today. I'm sorry, but it looks good. There's nothing.
I'm loving that example, JSON, you got on your screen now. I'm loving that.
Yeah.
That
Well, this is old.
encapsulates. Yeah,
This is very old.
it's but the thing is, it expresses the entire system.
Yeah,
in one
and
place.
I think it gives me a great boost to know that this is the essence of what it does is what we've been chasing all along. And now we know for sure that we arrived because this just fits right in.
Yeah, I agree.
One quirk is that when the face starts, you're going to not be able to change its sysprompt within the face. You need to make a new face or reload the face to get a different sysprompt to take on it.
2 seconds. No, that seems obvious and entirely acceptable.
Okay, cool. The agent interactions. So when an agent calls a remote agent, is starting to look like it will be entirely in natural language as opposed to a tool call.
Say that again.
When one agent calls another agent, it's not calling it by way of a well-structured tool call definition with a schema and all that. It's calling it using natural language.
Yes.
It's like, hey, I need you to do this thing, that thing, the other thing, blah, 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 blah. How's that?
Yeah.
Is that acceptable?
Yeah, and then it comes down to prompting about whether it's not acceptable. Going, dude, I'm a weather service. What are you asking me about recipes?
Okay. What have we lost by not being able to do a tool call out to an agent?
Well, the agent that you're calling, your NL interface still allows that other agent to have access to its own tools.
Correct.
So we've not lost anything because those tools are still being called on your behalf and on your request. It feels wrong to reach inside of another agent's tools.
I know, and tickle its tool belt. It's sort of weird, right? Like you shouldn't do that. Yeah, I'm a bit uneasy about this one, but I can't really see a way around it. I'll just see how it all shakes out. Maybe there's a need to go around it. Maybe it's perfectly fine. I don't know, but I can see a solution for a system in hand. I think I will have it either tonight or tomorrow or whatever. Like it's real fucking close. Everything I just described tonight sounds like it's in line with what your expectations are. So that's good. I have done a hell of a lot of probing to try and design this thing in a well-balanced way. I have considered many different ways of arranging these parts. I think I got a good one. When I come to you with these problems, it's really just like the leftover wrinkles that I'm like, either one of these sounds okay. I'm not sure
Yeah,
which one.
that's really evident. And on that last one, I think it would actually be an anti-pattern to be able to reach into another agent's tools.
Mm. But I mean, you
Um,
could make it that the agent needed to be called with like some form fields. Like if the agent was a car loan assessor, then maybe it's going to need like the amount of the loan, the location that the car is, your home
well,
address.
yeah, but that's down to the agent, the car loan assessor agent, to say, hey, you haven't given me enough information. I need
Oh,
this.
yeah, yeah, that's true. That's true. Yep.
I think the sanctity of that um, this JSON on the screen, the McApp,
Mm.
um, that should be um, the last stalwart. It's the fundamental piece, isn't it?
Yeah, well, the unit that we produce is the unit of agency, and this is the config file for it. It needs a new name. McApp doesn't sit anymore.
Names. We're never very good at names. Um,
I think for now I'll just call it an agent config. How about that?
well, yes.
Yep.
Agents, faces, views. Uh, um, should we call it something? No. Agents seems right.
It's an agent config file, is what it is. If we give it a
Yeah.
special name, maybe we don't need to. Maybe just agent config is just,
Yeah, and it produces agents.
yeah, the agent package.
Yeah.
Less new terms to learn. So the prompting balance looks like it shakes out as when to call an agent or not to call an agent, right? Like when the prompting about how to use an agent is more than the prompting within that agent on how to do the job, that means you've done something badly and you should have just kept the job inside the current agent.
That's kind of like a discovery horizon, isn't it? It's like,
Yeah, I don't know. I don't know how we're going to get around that one, but there's so where I'm trying to work towards is to give you some tools that you can start playing with these sys prompts, because that's really the key to the whole thing. Because you got to tell the agent how to call other agents and use them effectively. Like, when is it a good time to call another agent? I don't know. When should I go looking for an agent? I don't know. What agents should I know about by default in my sys prompt? Those are all
yeah, but at the
right.
moment,
These are all the issues.
you can only call agents you know about in the in your agent config, right?
Well, I
It
haven't
doesn't go out
coded
and
any of that
search.
in, right? You can,
Yeah, but it doesn't go out and search dynamically.
but it should be
So,
able to.
in which case, one of the agents would be a search agent. So,
Yeah,
prompt it saying, "Here's what you can do if you find you can't do what you want to do
right.
with any of
Yeah,
those
right.
agents.
Okay,
Go out
okay.
somewhere else."
Yeah, yeah. Fair enough.
And then you've
Oh,
got an agent to agent.
yeah. So I guess there's some calculations we can do actually, which is to do with like prompt size, like where you can assess how much of a system prompt is being used to instruct it on how to call a particular agent versus the size of the prompt within the target agent itself. And we can do some calculations that are like, that's a bad ratio, that's a good ratio, that's, like optimizing the construction of these agents is going to be our business for the next, probably from now till kingdom come, really. But
Yeah.
having little tools like that have these ratios and comparisons, like that's a deeper level of prompting than what we've seen in the wild so far, right? Because it's like now we need to really optimize these things.
Yeah, and I mean, there's a few things that are obvious there. It's like how many tokens. If I just called it directly and didn't, call through a
Mm,
tool,
mm.
the tool takes more tokens, and I would do it. I would just do it.
Mm. So all these things, right? And I don't know how I'm gonna give you the ability to edit that. I was just gonna make the first version where an agent can call another agent, and then from there we'll work on having a Git repo that stores these agent config files with some sysprompts, and then you can work on how do I tell this agent to make a new agent with a slightly different sysprompt, and how do I tell it to loop until it's improved. That's
Hmm.
your I want to say it's your problem, it's our problem, but how I'm looking to you to deal with that, because
Yeah.
I want to. There's still like this is a scaffolding. This is a
I'm quite comfortable with that.
and I want to be
I've
able to pass it off to you and be like, you need to tell me what to do. Are there missing system bits, missing functions?
Yeah,
I honestly
yeah,
don't think there is really, and it's really at best or at worst going to be a case of you coming to me saying, "Look, I tried to do this thing this way," and then you and I sitting down working out, well, the lay of the system is this, so maybe we can try these other paths. Um,
yeah. But um, I've tried a number of sessions now to you know poke holes on this, and this has been the most kind of boosting conversation we've had going through that file. It's like with that
right,
file,
right,
you can do everything that we've talked about. You can
right,
get an overseer.
right.
You
And
can
so you
get
when you
um,
prompt something, you can construct this file. You can prompt it to be good at constructing this file and experimenting, running experiments on executing this file, and
right.
then appraising the result and looping,
Yeah,
right?
yep, yep. And everything else is usage as opposed to architecture.
Yeah, which is kind of wild, man.
Yeah.
How much time you got?
Probably another 20 minutes.
Okay, I'll tell you the the gift I would like to give you. Uh,
Is that pony?
no, it's not. Hang on a second. Um, hang on a second.
How about a llama? I've always wanted a llama.
Um, hang on. Might have to go. Anyway, what I was thinking is that the issue is largely uh, when you have nested systems like tabbing systems within tabbing systems and all that. What I really think you want is I think you want or what I can give you is a little extension that goes in your browser
Yeah.
that connects up as a face to an agent, which gives the agent the ability to control the tabs you have open, the window layouts of the windows on your desktop, and to search through the contents of the tabs.
Oh, that'd be sweet.
And so, what you could do is you could run it at any point in time and then be like, um, purge, and then it would go through all your old tabs that know what time they were open, the cold, the stale ones, and all that. And then it would take a snapshot of what they were. It would scrunch down whatever info was to be gleaned from them. It would make it restorable, and then it would close the tab. And then it would also use that information in fulfilling your other requests that come in throughout the day, because it's like, oh, you were looking at this tab over here, you read this document over here, blah, 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 blah. And so it basically allows you to keep your tab count very low. It keeps the essential information out of it. It makes them recoverable. It considers what you were looking at whenever it answers any of your questions or has questions of its own. And it can do things like lay out the state board, because laying out the state board is really just taking a tab and resizing one of them like that, and then another one to take up the screen here. And so you can chat in this window and be like, oh, I want to see a map of something, something. And then it could fire up a whole new browser window that it had just navigated to for you.
That would be awesome.
And then you're free, right? Like you're able to chat with your tabs. You can browse. It knows what you looked at and it manages it. It keeps track of it and knows that you use them like tasks or things to do. And it helps you with all that.
Yeah, exactly. And it would, I don't know, call it tab anxiety. I don't close tabs.
Yeah.
I was thinking, I'll get back to that.
And you're worried about what you're going to lose. But, okay, so that sounds like a good thing, right?
Yeah, sounds
all right.
Awesome.
All right, I'll make it that thing. I better go. Is there anything else that you need to cover from your side?
You want to stop the recording?
Yep, sure.
One other thing.